chemical calculations. හරිනේ මේ chemical calculations ටික තමයි තියෙන්නේ කරන්න. ලියමු මෙන්න මෙහෙම chemical calculation කියලා ලියන්න එපා. sorry ඔක කියලා ලියන්න ඕන chemical composition of a mixture. right calculations කියන්නේ commonly හැම එකටමනේ chemical composition of a mixture. sorry ලියන්න ඕන chemical composition of a mixture කියලා. අපි ඒක ගැන තමයි calculate කරන්න හදන්නේ. right chemical composition of a mixture. chemical composition of a mixture. Okay, let's write like this. Chemical composition of a mixture. Chemical composition of a mixture. Chemical composition of a mixture is the distribution of components. Chemical composition of a mixture. Chemical composition of a mixture is the distribution of components. Sorry, distribution of individual components is the distribution of individual components in the mixture. Chemical composition of a mixture is the distribution of individual components in a mixture. Right? ඊළඟට දෙක ගන්න. Chemical composition of a mixture can be expressed in different ways. ඊළඟ point. Chemical composition of a mixture can be expressed in different ways. Chemical composition of a mixture can be expressed in different ways. Chemical composition of a mixture can be expressed in different ways. මේකට අපි පොඩ්ඩක් communicate කරලා වැඩේ කරගමු. Meantime මේ ටිකක් quick වෙමු හරිද? right. දැන් ලියන්න number 1. Again, chemical composition of a mixture can be expressed in different ways. So we're going to talk about different ways how the chemical composition is represented in a mixture. So there are different ways. Like we're going to talk about different ways. So all of these methods can be used to demonstrate or represent the composition of a mixture. Depending on the type of the mixture, we can choose any other comfortable way of indicating the composition, right? So number one, we're going to write the number one method. Number one method, expressing the composition of a mixture. Expressing the composition of a mixture. Number one, expressing the composition of a mixture in terms of a mass fraction. Expressing the composition of a mixture in terms of a mass fraction. Expressing the composition of a mixture in terms of a mass fraction. So in front of this heading or whatever the thing you wrote just now, mass fraction, mass divided by mass. Okay, so we are going to indicate the composition of a mixture as a mass fraction. Okay, so we are going to indicate the composition of a mixture in terms of mass fraction. So this is how we do it, right? So we have a general equation to indicate the composition of a mass indicate the general composition of a mixture in terms of mass fraction. So mass fraction of a component equals mass of the component divided by the total mass of the mixture. Right. This is the equation. This is the way that we use to indicate the composition of a mixture in terms of mass fraction. So we're going to indicate the composition of a component, the distribution of one component in terms of mass fraction in the whole mixture, right? So in the heading, expressing the composition of a mixture in terms of mass fraction, you should have written this, and under that you have to write this equation. This is the equation that we are using here to indicate the distribution of particles in a mixture in terms of mass fraction. I'll just explain it what will be done here, so then it will be very easy for you to cope up. Right? This is not it's not a hard thing. And we'll go with the calculations, right? Once after the equation, we'll go with the calculation, so then that's easy. Harith, are you done with noting down this? Yeah, Buddha.
So you should note down the equation under the point, right?
Yeah. It was not a point. It was kind of a like a heading.
First way,
express it. Yeah. So under that, you have to note it down.
Okay, sir.
Right. So then afterwards, okay. So then we go for a question. Right? We go for a question directly. We can use the data given in the question to substitute in this equation, and then we'll work out the equation directly. Right. So write a question. Right. 1 gram of salt. 1 gram of salt. 1 gram of salt. Now, write it really. 1 gram of salt is mixed with 9 grams of sugar. 1 gram of salt. 1 gram of salt. 1 gram of salt is mixed with 1 gram of sugar. Now this is the mixture, right? Are api ara acharu walata ganne, right? Api ara acharu hadana acharu එක ඒවා හම්බුනහම අමු ඒවා හම්බෙච්චහම, right? Like you all know it, right? ඔකට මේ ලුණුයි සීනි අය මිරිස් චුට්ටකුත් දානවා දාලා අපි හදාගන්නවා එක සීන් එකේ ඒවා so like thing like that. හරිද මිරිස් නෑ කියලා හිතන්නකො. So we are going to make some sort of a paste like thing with this salt and sugar. So for that we have actually used 1 gram of salt with 9 grams of sugar, right? So to make that mixture, ඕක තමයි අඹ වලට හරි අමු අඹ වලට හරි අමු වෙරළු වලට හරි මොනාට හරි දාලා කන්නේ, right? You all like it, right? So then most of you all, right? මේ ඒක හදාගන්න ගන්න mixture එකක්. So the total mixture contains 10 grams if you see it clearly, right? Because 1 gram of salt is here and 9 grams of sugar is here. Totally you have 10 grams of total mixture, right? So you have actually used 2 components to make this mixture. So I'm asking, continue the question. 1 gram of salt is mixed with 9 grams of sugar to make a mixture. And then write. Find the mass fraction of sugar and salt in the mixture. Find the mass fraction of sugar and salt in the mixture. So then I'm asking the mass fraction of salt. Okay, mass fraction of salt and sugar as well. So I'm asking you to find out the mass fraction of sugar and mass fraction of salt, right? So first of all, we can find out the mass fraction of salt, right? So mass of salt divided by the total mass of the mixture, right? Now, what is the mass of salt here in the mixture? 1 gram, okay? 1 gram of salt is here. What is the total mass of the mixture? You have 1 gram of salt and 9 grams of sugar. So altogether you have 10 grams, right? 10 grams is the total mass of the mixture. So then this gram can be cut off with this. So 1 over 10, that is the fraction. That means out of 10 components, when you talk about the mass basis, out of 10 portions, 1 portion is salt. So for every 10 portions, 1 is salt, right? So that's what you have to understand. Now, when you talk about this composition of the mixture in the mass basis, out of 10 parts, 1 part is salt, right? So did you get this, what I'm telling to you? Is it clear? How do you express the composition in the mass fraction? Yeah. So quickly go for this calculation, and then I want you to find out the mass fraction of sugar here as well. Right? Do this calculation and then write the equation again to find out the mass fraction of sugar as well. Alicia, was it clear to you? Upe, is it clear to you? Shanu, what about you?
Clear, sir.
Yes, sir.
Upe? Upeka, is it clear to you? She's dropped, I think. Bimsen Malli, වැඩේ හරිද? මේක තේරෙනවද? අපි මේක කරා නේද class එකේ physically? Right, okay, right. All right. Upeka dropped down, I think, Shanuki.
Yeah, so just now.
Yeah. Okay, do the math very quickly. Don't take too much of time. Should be doing the calculations very fast because I want to finish up the chemical composition part today, so then we can go over the next session on the next day. So basically, that with that, all the writing part of this system will be finished, and then I'll be sending you a tute to talk about the physical separation methods. So are we done with this part, guys? Can we move on, people? Upeka is here. Upeka, what happened?
Sir, the power came back.
All right, okay. Is it clear to you what I just explained?
Yes, sir.
You were there, no, until the calculation was done?
Yes, sir.
Okay, perfect. All right, Upe, I wanted to find out the mass fraction of sugar as well.
Okay, sir.
Am I late? Right. So quickly, let's do the calculation for the mass fraction of sugar. Right. So what I have to do here, mass fraction of sugar. So we will be calculating the mass fraction of sugar, right? So mass of sugar here and mass of the total mixture. Mass of sugar is 9 grams actually. Mass of the total mixture is 10 grams. Grams to grams cancel off, so 9 over 10. So out of all 10 portions, 9 portions are sugar in this mixture. So put up your hand if you have got this answer. Okay, perfect. Right, Upeka, quickly do the calculation. Okay, so then the second method of indicating the composition, right? Write the heading, expressing the composition of a mixture, expressing the composition of a mixture, expressing the composition of a mixture in terms of a volume fraction, in terms of a volume fraction. Right, expressing the composition of a mixture in terms of a volume fraction. In terms of a volume fraction. So then we are going to now basically you will have an idea. Okay, now if we are going to indicate the composition of a mixture in terms of a volume fraction, the mixture has to be something that is measured with volume. So it has to be obviously a liquid mixture, isn't it? Because most of the time now, when you have solid solute, now a mixture like before, like salt and sugar is mixed, can you calculate the volume of those components? No, right? So when we are talking about that, we are going to indicate the composition of the mixture in terms of volume fraction. So you have to have an idea. Okay, then now we are going to indicate the composition of a mixture which is in the liquid state, right? So volume over volume, in the sense both the solute and the solvent has to be liquids. So then, because volume over volume we are going to indicate, so then both the components in the mixture, the solute and the solute, both of them are going to be liquids, right? So equation for that is volume fraction of a component, same like before, volume of a component divided by total volume of the mixture. Okay, go for this equation, general equation. Is it difficult for you all to see when I write with the blue color? Is it not clear? Guys, I want your idea. Shape the pain or the Amaru Balagan Shanuki.
That's so clear cut pain.
Shape, ne? But black works better than this, ne? Black and red work better than this, ne?
Anything, sir.
Okay, right. Right. Hope you're done with this, and I want you to write the question. Right? Question. 125 ml of ethanol, 125 ml of ethanol is mixed, 125 ml of ethanol is mixed with 1000 ml of water, 1000 ml of water to make an ethanol solution. Find the volume fraction of ethanol and water. Quickly do the calculation. Find the volume fraction of ethanol and water. Find the volume fraction of ethanol and water. Right. So in the mixture, I have dissolved 125 ml of ethanol with 1000 ml of water. That's what I have done. Right. So I want you to find out the volume fraction of ethanol first. Right. Ethanol and then the volume fraction of water. I think I said it right. Find the volume fraction of ethanol. You should write it. Find the volume fraction of ethanol and water. So do the calculations very quickly. I'll give you like 1 minute to do both. It shouldn't be very nice margins at the end. Now you should do the calculation very fast. Done, guys. Shall we move on? Volume fraction of ethanol. What is the volume of ethanol present here? 125 ml. Okay. Total volume would be 1000 ml plus 125. So altogether, the total mixture contains 1125 ml of things. 1125 ml. 1125. Okay. So 1 ml to ml cancels off. So for 125, there's 1. So for 1125, there are 9 125s. Okay. So 1/9 would be the composition of, right? The volume 1/9 would be the ethanol's volume fraction. That means when you talk about the composition of the mixture in terms of volume basis, out of nine parts, 1 part is ethanol, right? When you talk about this mixture in terms of volume basis, out of 9 parts, 1 part is ethanol. Did you get this answer, guys? Girls, did you get this answer? Beam said, it's something similar to this. Oh, right. Okay. Upe, harida calculation.
Yes, sir.
Right. Okay. Did you go for the volume fraction of water as well?
doing it, sir.
Okay, do it. Volume fraction of water. අනිත් දෙන්නට ආවද එලීනංගි ෂනු ආවද උත්තරේ?
Yes, sir.
එලි?
Yes, sir.
Did you get this answer?
Sir, no, I used the calculator, but I got 8, like 1 over 8.
හරිනේ බබා, like මෙහෙමනේ for 1000 125 වේව අටක් තියෙනවා. ඒ total mixture එක නම් 1000 නෙමෙයිනේ. Can you total volume of the mixture 1000 නෙමෙයිනේ. ඒ 1000 ml water තියෙනවා 125 ml ethanol තියෙනවා. ඔය දෙකමනේ total mixture එකේ ඉන්නේ. Did you get that?
Yes, I understood.
Right. So then in the total mixture you have 1125 ml. ඒක 1125 ml වලට 125 වේව තියෙනවා 9ක්. හරි නේද?
Oh, sir.
Yeah, perfect. Right. So then volume of water is 1000 ml, and the volume of total volume of the mixture 1125 ml. So for this one මෙතන තියෙනවා 8 over 9. 8 over 9 තියෙනවා. So for every 9 parts, when you talk about for every 9 parts, 8 of them are water particles, right? 8 of them are water parts when you talk about the composition of this mixture in terms of volume basis, right?
Excuse me,
Right.
sir.
Yeah.
So like when you solve like these equations, definitely you need to write that equation, no, the long one.
Like since we are practicing them, just write them, right? But like if you are given this calculation to be done in a essay type question, you need to present the equation, and if it is like a structured essay, again you have to present it. But if it is like an MCQ, there's no need. If you know the way how to do it, no need to present them the calculation. So
Yeah.
for obtaining the final answer is okay, but for essay type and for structured essay type, you will need it. So better you keep it in your mind.
Okay, sir.
Okay, right. The third method of indicating the composition of a mixture, right? Third method, ලියාගන්න heading එක. Third method, expressing the composition of a mixture in terms of mole fraction. Expressing the composition of a mixture in terms of mole fraction. Now here you have a calculation part, right? මෙතන පොඩි calculation part එකක් තියෙනවා. Mole fraction, moles over moles, mole over mole, right? As a mole fraction. So the equation mole fraction of a component equals number of moles of a component divided by the total number of moles. Total number of moles in the mixture. Right. I'll give you a question. Note down the general equation. And I want to do the calculations alone, right? Hereafter, I mean, I'll give you some time to do the math, right? So then write the question. 1 mole of glucose, 1 mole of glucose, question, 1 mole of glucose is dissolved in 4 moles of water. 4 moles of water. 1 mole of glucose is dissolved in 4 moles of water to make a glucose solution. To make a glucose solution, 1 mole of water is dissolved in 4 moles of 1 mole of glucose is dissolved in 4 moles of water to make a glucose solution. Find a mole fraction of glucose and water. Find a mole fraction of glucose and water. Do it alone. I'll give you like 1 minute.
Vanessa, could you repeat the question again?
Yeah, okay. 1 mole of glucose is dissolved in 4 moles of water. To make a glucose solution, find the mole fraction of glucose and water. And do it separately. Find the mole fraction of glucose and water. Okay, do it. Guys, done? දෙකම කරලා ඉවරද? මේක ලේසියි. මහලුකු කේස් එකක් නෑ. Mole fraction of glucose, right? මෙතන mole fraction of glucose. එතකොට මෙතන number of moles of glucose එන්න ඕනේ, right? එතකොට number of moles of glucose 1 total mixture එකේ number of moles පහක් තියෙනවා. දැන් අපේ කට්ටිය වරද්දෙන් තමයි උක තමයි. So when you do the calculation, you will think that the remaining part of water molecules will be the total number of moles in the mixture. No, total number of moles in the mixture is the total number of moles of all components present in the mixture. So altogether, like 1 glucose mole and then 4 moles of water. So altogether 5, right? So 1 mole of glucose and 5 moles of 5 moles will be the total number of moles of the mixture. So then moles to moles cancel out. So 1/5 would be the mole fraction of glucose in the mixture. So for every 5 moles, 1 mole of components will be glucose. So if you have got this answer, you're correct. Answer. Right, shape, make it lazy. Right. So the next one is also lazy, right? Mole fraction of water, isn't it? Right? Number of moles of water divided by the total number of moles in the mixture. Now the number of moles right? 4 moles, total number of moles 5 moles. Okay. So then moles to mole cancel off. So 4/5 would be the total number of moles in the mixture. Right? Okay. So then if you have done this, I want you to give you another question, right? Like this. Still about the mole fraction, right? Still about the mole fraction, namely under. All right. 18 grams of water. 18 grams of water. This is the question, right? 18 grams of water. 18 grams of water is mixed with 40 grams of sodium hydroxide. 80 grams of water is mixed with 40 grams of sodium hydroxide. To make a sodium hydroxide mixture, 80 grams of water, 18 grams of water is mixed with, 18 grams of water is mixed with 40 grams of sodium hydroxide to make a sodium hydroxide mixture. Find the mole fraction of sodium hydroxide and water. Find the mole fraction of sodium hydroxide and water. Now, this is another question under the same way of representing the composition. Moles over moles fraction indicate. But in this case, now I have not indicated, I have not given the number of moles of what I have added into the mixture. I have not indicated the number of moles of sodium hydroxide I have added into the mixture. Now you have a work done. Mixture total number of moles components number of moles. Now what I have done, I have just given the mass of the solute what I have added into the mixture, but not the number of moles. Okay. So in this case, before you find out the mole fraction of, we have to find out the mole fraction of water, right? We have to find out the mole fraction of water. Let's see, mole fraction of water. So mole fraction of let's see, mole fraction of water. How to find out the mole fraction of water? Number of moles of water divided by the total number of moles in the mixture. Total number of moles in the mixture. That's how you calculate it. No? So then now the problem is in the mixture, I have given you only the masses of the components, but I have added into the mixture, but not the number of moles. So first of all, you have to calculate in that mass of a component, how much of moles would be present. So to calculate that, first of all, I should give you the relative atomic masses of all these elements. Hydrogen's relative atomic mass is 1. Oxygen's relative atomic mass is 16. Sodium's relative atomic mass is 23. So that's it you want, right? So by knowing the relative atomic masses of these elements, you can calculate the relative molecular mass of each of the compound that I have given you, right? Then you can work out the N equals M over M equation, and you can find out the number of moles present here. So this is how you do it. You can find out number of moles of water, number of moles of water, number of moles of water. First of all, do the calculation, number of moles of H2O. Okay, how to do that? You have to work out M equals M over M equation. So in this case, M is the given mass. You know the given mass of water, but you don't know the molar mass of water. How to do that? So take the water molecule H2O. In that, what is the relative atomic mass of hydrogen at 1? How many such hydrogen atoms are here? 2. And then what is the relative atomic mass of oxygen? 16. 16. So 16 plus 2 is what? 18. G mole minus 1. This is capital M of water, molar mass of water, right? Capital M of water is how to find out the capital M of water, molar mass of water. You have to give, I have given you the relative atomic masses of each elements present in the water molecule. So you have to calculate the relative, total relative atomic masses of each element present in the molecule. So then you will get the relative molecular mass. How? Hydrogen's relative atomic mass is 1. You have 2 such hydrogen atoms, so 1 has to be multiplied by 2. And plus there is an oxygen atom. 16 is the relative atomic mass of oxygen. So altogether, when you calculate it, you will get 18 G mole minus as the molar mass of water. So now we have the given mass of water, that is what? 18 grams. 18 grams. What is the molar mass of water? 18 G mole minus 1, right? Grams to grams cancels off. 18 divided by 18 is 1. So how many moles of water was present in 18 grams? There's only 1 mole. So when you added 18 grams of water into this mixture, you have added how many moles? 1 mole of water, right? You have added 1 mole of water when you added 18 grams of water into the mixture. Are you guys clear with that? Just tell me that. Are you guys clear with that? How did we do the calculations? Girls, talk to me. Are you guys clear with that?
Yes, sir.
Yeah. Upeka?
Sir, can you do it one more time?
Yeah, sure. Shanuki, what about you?
Yes, sir.
Right.
So
Now,
we need to like memorize these atomic number, like.
no, basically, I will be giving them all the time.
Okay, so in the paper also
Paper does the same. Paper does the same.
Yeah.
Okay, right. So then, Upeya, see here. Now, Upe, what I have done here, in the previous question, can you remember that I clearly gave you the number of moles in the mixture? Can you remember?
Yes, sir.
Now, in this case, what I have given you, I have not given the number of moles present in the mixture out of any of those components. What I have given, I have just indicate how much of mass of those components are present in the mixture. That's what I have done. Clear?
Yes, sir.
So then you have to calculate, Upeka, in this mass of components, like in 18 grams of water, how many number of moles would be present? So I have added 18 grams of water. So then you need to find out how many number of moles would be present in 18 grams of water. Is it clear?
Yes, sir.
Yeah. So to do that, we have to work out the equation called N equals M over N. Okay.
Okay, sir.
Okay. So then you can describe the equation somewhere in your book. N equals M over M. In this, N tells you the number of moles. Simple M tells you given mass. Let's say like that. Capital M tells you molar mass. Simply define it somewhere. Now you have the book like this, no? Somewhere over here, just define it. This whole thing. N equals M over M. M is the molar mass. Simple M is the molar mass. Capital M is the simple M is the given mass. Capital M is the molar mass. And N
Okay,
tells
sir.
you the number of moles. Right. Okay. Now, by using this equation, Upeka, we need to find out how many number of moles will be present in 18 grams of water. Is it clear?
Yes, sir.
Yeah. So how do you do that? We know the given mass of water, right? We know the given mass of water, that is 18 grams, isn't it?
Yes, sir.
Yeah. But we want to find out the molar mass of water. Molar mass of water. Okay. How to do that? Write the water molecules. Tell me, Upeka, what is the relative atomic mass of hydrogen?
1.
How many such hydrogen atoms are present in this water molecule?
2.
Okay. So then, 1 into 2 will be the total mass of the hydrogen atoms in the molecule, isn't it?
Yes, sir.
Right. What is the relative atomic mass of oxygen?
16.
60. So altogether, what would be the molar mass of water?
18.
18. We have to indicate it with the unit G mole minus 1. Okay. So what is the molar mass
Okay,
of water? 18 G mole minus 1, isn't it? So then we found out the molar mass of water. We can substitute it here, 18 G mole minus 1. Can you see that the grams to grams cancel off?
Yes, sir.
18 divided by 18 is 1, right?
Yes, sir.
And then minus mole goes up and it becomes a plus mole. Can you understand? So
Yes,
now
sir.
you have found out in 18 grams of water, how many number of moles would be present?
1.
1 mole. So you have to do the same thing, Upeka, to sodium hydroxide, right? So what do you have to
Okay,
do?
sir.
So here we have found a number of moles of H2O. Let's do it for the water also, right? So number of moles of NaOH. How to do that? Work out N equals M over N. Upeka, tell me how much of sodium hydroxide I have used here?
40 grams.
40 grams exactly, right? 40 grams, right? So we need to calculate the molar mass of sodium hydroxide, isn't it?
Yes, sir.
Molar mass of NaOH. So we have to write the NaOH molecule. Upeka, tell me the relative atomic mass of sodium.
23.
Relative atomic mass of oxygen.
16.
Relative atomic mass of hydrogen.
1.
Altogether, 40 G mole minus 1 would be the relative molecular mass, molar mass of sodium hydroxide. Do you get that?
Yes, sir.
So then write the capital M of sodium hydroxide. That's 40 G mole minus 1. Okay. G to G cancels off. 40 divided by 40 is 1. Minus moles becomes a plus mole. So when you add the 40 grams of sodium hydroxide, how many moles of sodium hydroxide you have added? 1 mole again. Now, Upeka, tell me in the mixture, how many number of moles are there? Total number of moles. How many total number of moles are there?
2.
Out of them, 1 mole would be?
Water.
1 mole, other mole would be?
Sodium hydroxide.
So then you can do the calculation, right?
Yeah.
Yeah. So the thing was like you need to do a pre-calculation before you enter the final calculation. Like earlier, the stuff was very easy, right? We had to directly substitute the values in the final equation and get the answers as a mole fraction or volume fraction or a mass fraction. But now things are getting a little complicated. You need to do some pre-calculations before you enter the final equation. Can you understand?
Yes, sir.
So, so what you have to do, you have to work out N equals M over N equation. So be careful. The simple M tells you the given mass and the capital M tells you the molar mass. So to find out the molar mass, you need to know the relative atomic mass of the elements present in the molecule. That is mostly given in the paper. And that's mostly given in the paper, or else like when we are doing these calculations, little by little, we'll like get familiar with them. Are you guys okay with this Elisha and then Upe? Sorry, what do you call it? Shanu?
Yeah, so clear.
Bima shape Bima. Right, okay. Do the math quickly. Don't take too much of time. It's not godak loku neya. It's very simple. So do it very separately, right? So then you will understand everything. First write this, and then relative atomic mass of these elements, find the number of moles of water, and then find the molar mass of water to do that. Then find the number of moles of sodium hydroxide and find the molar mass of sodium hydroxide to do that. Then when you get the number of moles in the mixture, you can substitute the values in the equation and get the final answer.
Sir,
Yeah.
so sir, if they give a question like this where you have to find the mole fraction by giving in grams, then sir, all the time you will get only 1 mole, right? When you have to find the mole?
No. I made it easy for you.
That's what I was also wondering. Like,
No, it's not a problem. Like මෙතන මොන number of moles ආවත් අර equation එකට දාලා you can simply do it. It's not a problem. Don't worry about it. Now it's now මෙතන මොන number එක ආවත් like you will be given a number which would be divided by this number. Can you understand? මෙතන දෙන number එක the grams of the component what they give you would be most of the time a number which would be simplified by this number. Can you understand?
so like when we like take the second one, it's in a 40 millimeter 80 hours, it's 2 moles, like something like that.
Yeah. Simply. Oh, ඒක තමයි.
Oh, okay, sir.
And මෙතන 20 එන්නත් පුළුවන්. So then 20 divided by 40 would be 0.5. Yeah. එහෙම තමයි එන්නේ. It's not that hard. I was thinking, right? Okay, they've cut here because like now y'all physical classes now these things, how do you come to know about all of these calculations regarding n equals m over m? That is based on the lesson what we have discussed in grade 10. That was the lesson quantification of elements. Lesson right? So in the physical classes, before we start this lesson, we had a seminar to do only that lesson again, right? So like y'all actually missed this chance because we had a time, like it was a very rainy day anyway, like so then we had 2 seminars actually. We have 2 batches. They got time slots. They got there like it took about 3 hours to finish the session for one class. Game time for the second class also. Like we had a seminar. Like they revised the whole lesson again from the right beginning to the end, and then they know like you had to revise this equation. That's what I was taking much of a time for you all to explain these things, because I know that you might have forgotten the things what we have learned in grade 10 and you might have difficulties when you're doing that. I think you were not there with me for that lesson. Were you there with me for that lesson?
No, sir. Me, Alicia, we both.
So we actually had 3. I hope you have make a calculate කරගත්තද කට්ටිය? මේක දාගත්තද note කරගත්තද ළමයි?
Yes, sir.
Right. Okay.
Yes.
So then number of moles of mole fraction of water, number of moles of water කීයක් තිබ්බද? 1 mole තිබ්බා. Total number of moles කීයක් තිබ්බද? 2ක් තිබ්බා. Right? මේකට මේක කියපුවම 1/2 තමයි mole fraction of water. I hope you have got this answer. Right? ඊට පස්සේ අපිට calculate කරන්න වෙන්නේ mole fraction of what did I added there? Sodium hydroxide නේ. Mole fraction of sodium hydroxide. NaOH, sodium hydroxide moles උත් එකයි, mixture එකේ total moles දෙකයි. එහෙනම් ඒකටත් එන්නේ half. Okay. Right. Now guys, මට මෙන්න මේක පොඩ්ඩක් ඔයාලට තේරුම් කරගන්න ඕන. Before that, write a point like this. So after writing this, we are done with that, completely done with that, and then write a point like this. Write a point like this. A special point with a different pen, if it is possible, that's better. Write like this. There are no units for mole fraction, mass fraction, and volume fraction. There are no units for mole fraction, mass fraction, and volume fraction. There are no units for mole fraction, mass fraction, and mole fraction. Mole fraction, mass fraction, and volume fraction. No units. We actually experience it. Unit cuts off because we are indicating the composition as a fraction, so there are no units. Then the next one, write it down, then I'll explain. The summation of mole fraction mass fraction and volume fraction of a mixture, the summation of mole fraction, mass fraction and volume fraction of a mixture should be equal to 1. The summation of the mole fraction, mass fraction and volume fraction of a mixture should be equal to 1. Okay. Right. Okay. So then make a product balanda, right? Shanuki, Elisha, balanda maker. Upeka, now tell me, mole fraction of sodium hydroxide in the previous mixture was half neither. Half out of two moles in the mixture, 1 mole was sodium hydroxide.
Yes, sir.
Okay, so then mole fraction of, we actually calculated the mole fraction of water as well. Mole fraction of water also, 1 mole was divided by 2 moles in the total number of moles. So it again became half. Like that means 1/2. That means out of, now in the mixture, out of 2 moles, 1 mole is water. In the same mixture, out of 2 moles, 1 mole will be sodium hydroxide. Can you understand?
Yes, sir.
So if you have this total mixture, in this total mixture, 1 mole is water and the other mole is sodium hydroxide. So out of 2 moles in the mixture, like you have 1:1. Half of the moles in the mixture are water moles, half of the mixture moles in the mixture are sodium hydroxide moles. Can you understand?
Yes, sir.
So when you add the mole fractions, so half and half, when they are added, what would be the total summation of the mole fractions? Mole fraction of water and the mole fraction of sodium hydroxide. When you add the mole fractions of the components in the mixture, what would be the summation? Anybody can answer. Half and half added together, the mole fraction of sodium hydroxide is 1/2. The mole fraction of water is 1/2. When the mole fractions of the two components are added, what would be the final number of final value?
1.
1. It has to be 1. එහෙනම් ශනුකි හැම mixture එකකම ඕක වෙනවා. ඒ කියන්නේ දැන් අපි හදන්නේ ultimate now in the sense අපි ගත්තොත් මෙන්න මෙහෙම case එකක්. Imagine අපි ගන්නවා මේ ethanol ඈ. ඔන්න ඊළඟ example එක ethanol mix කරනවා මම ethanol mix කරනවා 250 ml water mix කරනවා මම 750 ml හරිද? දැන් ශනුකි ethanol වල mole fraction එක ethanol වල volume fraction එක ගන්නකො 250 ml total mixture එකේ කොච්චරක් තියෙනවද මේ volume එකක්? මට කියන්න total volume එක කීයද mixture එකේ?
Ethanol, right?
Yeah, no. Yeah, we are going to find out the mole fraction of ethanol. I have a mixture. This is the mixture. 700 දැන් අලුත් එකක් ඈ 750 ml of water is mixed with 250 ml of ethanol. So I'm finding out the mole fraction of, volume fraction of ethanol.
So 40 grams, right?
නෑ නංගි. I'm making another new mixture in which 250 ml is ethanol and 750 ml is water. So how to find out the volume fraction of ethanol? How many volume or how much of volume of ethanol is present?
250 ml.
250 ne. So මේ mixture එකේ total volume එක කීයද?
750 plus 250.
That is 1000 ne.
Yeah.
Okay, so then when this one cuts off with this one 104 ne දෙන්නේ.
Yes, sir.
හරි. ඊට පස්සේ මම හොයනවා ඕකේම volume fraction of water. ශානුගේ මේ එලීෂා බලන්න, උපේක බලන්න volume fraction of water. කීයද volume fraction of water? 750 නේද 50 ml නේද water තියෙන්නේ?
Yeah, 750 divided by 1000 ml.
1000 ml නේ. එතකොට මෙතන ඉන්නේ 3/4 නේද?
Yeah, sir.
මේ දෙක add කරපුවම 1/4 plus 3/4 add කරපුවම කීයද එන්නේ?
4/4
4/4 නේ. ඒ කියන්නේ 1 නේ. නේද? දැන් මෙතන හතරෙන් එකක් තියෙන්නේ ethanol. ඉතුරු හතරෙන් කෑලි හතරකින් එකක් තියෙන්නේ ethanol උපේක. හරිද? කෑලි හතරකින් වොලියුම් බේසිස් ගත්තාම මේ මික්ස්චර් එකේ වොලියුම් බේසිස් එකකින් ගත්තාම කෑලි හතරකින් එකක් ethanol උපේක. එතකොට ඉතුරු තුන මොනවා වෙන්න ඕනද උපේක?
water.
එහෙමනේ. ඉතුරු ටික water වෙන්න එපා. එතකොට මේ වොලියුම් ෆ්‍රැක්ෂන්ස් දෙක එකතු කරපුවාම ෆයිනලි එන්න ඕනේ මොකද්ද?
1.
1. එහෙනම් තේරුණාද? එලීෂා එක තේරුණාද?
Oh, sir.
ඕනම මික්ස්චර් එකක වොලියුම් ෆ්‍රැක්ෂන් components ඔක්කොගෙම වොලියුම් ෆ්‍රැක්ෂන්ස් එක එකතු කරාපුවාම when you get the summation of the components of all when you get a summation of the all components, when you talk about the volume fraction, mass fraction and mole fraction, ඔය ඕනම එකක components වල summation එක එකතු කරාම you will get the answer as what? 1. 1 වලට වඩා වෙනස් answer එකක් ඔයාලට හම්බ වෙනවා නම් your calculation is wrong. Okay, so that means write a point like this. Did we write the point, Chanuki?
So we wrote a point called there are no
units. Okay, write like this.
So you should write the point and write the things on the board.
No. There's nothing to be written. I just explain it for you all to understand. Yeah, that's only a point. Write like this. The summation of mole fraction, comma, mass fraction.
So
And
Sir, I think you gave this point.
yeah,
Okay. Summation is 1. Did I finish it?
Yeah.
yeah, sir.
Equal to 1.
Yes, sir.
All right. Okay. Perfect. So then you have to highlight it. That's it. And then, so we have up to now we have discussed 3 methods to express the composition of a mixture. Up to now we have discussed 3 methods to express the composition of a mixture. And there are like now these 3 methods could be like these 3 methods could be used in data representation. These 3 methods could be again further described with another 2 methods. I will be talking about that also. Write a point like this. Now this is not a number which is continuously written as 1 2 3. 3 is done and we are talking about separate another 2 methods. Okay, so write like this. Write another heading actually, expressing the composition of a mixture in terms of a percentage and parts per million. Expressing the composition of a mixture in terms of expressing the composition of a mixture as a percentage and parts per million. Right? ppm we say. Expressing the composition of a mixture in terms of expressing the composition of a mixture as a percentage and parts per million. Done. So then අපි ඉස්සරලා indicate කරන්නේ composition එක indicate කරන්න use කරපු methods තුනම percentage එකක් විතර indicate කරන්නත් පුළුවන්, ppm එකක් විතර indicate කරන්නත් පුළුවන්. ඔබ බෙන් සෙදහන් පුතා. million parts per million. Oh, ppm parts per million. Billion කියන්නේ 10 to the power 9 නේ. Million කියන්නේ 10 to the power 6. Done. So then write Roman number 1 and write expressing the composition as a percentage. Under the heading you just wrote, write Roman number 1 and write expressing the composition as a percentage. Expressing the composition as a percentage. Okay, so then you have a general equation for that. Composition as a percentage equals fraction into 100%. You can note it down. Okay, done. Shanuki, have you seen these liquor bottles?
Yes, sir.
Okay. What about Upeka
Yes, sir.
and Elisha?
Yes, sir.
Okay, perfect. Bima, දැකලා තියෙනවනේ කොහොමද? අපි කතා කරන්නේ physical class එකේදී උන් right? අට chat එකක් දැම්මේ. Right? Okay. So in that have you seen ඔයා හිටියේ නැද්ද? Sunday class එකේ බිමා. අම්මා. ඒක ගියා chat එක පැයක් විතර. ඒ දුනියේම ඉන්නවනේ. ඒ කාර්යයක් කරා. Right? Right. So in these liquor bottles, right? Okay. Now you guys got to tell me something, right? Okay. So so in some liquor bottles, right? In some liquor bottles, මෙන්න මෙහෙම ගහලා තියෙනවා. In some liquor bottles මෙන්න මෙහෙම ගහලා තියෙනවා. කොහොමද? 40. Right? In some you have like this. Okay, right? Then imagine these are two alcoholic beverages, two alcoholic beverages. In one, it is indicated as 40%, and in the other, indicated as 8.8. Okay. Now you want to give me an idea, right? Okay, just for the humor, right? Okay. Upeka, what do you think would be better? I'm just asking, just your idea, right? You might know, you might not know, no problem. Just give you idea. What do you now? If you know it, that's better, right? What do you know? What do you? I'm not talking about the taste, right? Alcoholic beverages I like. Bunde katti very very. So in that mind, what would be better? Now, I'm going to explain what this means actually,
Yes, sir.
right? Yeah.
So that means
So what do you mean better? You mean like strong?
Again, yeah, exactly. Strength. Let's talk about the word strength. Yeah, it didn't come to my mind. Okay, strength. Yeah, 40% of the 8.8 is better. What do you think?
40.
Yeah. So most of the whiskeys comes with this value, no? Right? Whiskeys comes with this value, right? Now, what is the 8.8 percentage? Most of the beers in Sri Lanka, ne? Beers in Sri Lanka is the 8.8 value comes up with, and whiskeys comes up with vodka වගේ තමයි 40% තියෙන්නේ නේ. Right? Most of the whiskeys 40 වලට ලං වෙන්න එනවා නේ. Right? Okay. So then make it right that we just now most of the people, right? Most of the people know it like this. Okay. 40% now Honda is strong. 8.8 now වැඩක් නැහැ. So what really does this mean, right? This now in these liquor bottles, guys, they actually represent this as a volume percentage. They actually represent this as a volume percentage. That means, guys, now if you talk about a liquor bottle, like let's talk about a 1 liter whiskey bottle. Okay, if you talk about a 1 liter whiskey bottle, right? If you talk about a 1 liter whiskey bottle, in that out of that 1 liter, when you talk about a volume, when you talk about volume basis, volume, Lamai, you just have to know it. Pure alcohol, 100% alcohol cannot be consumed, right? It's like you have, I know that you have this idea of this burning sensation of acids that is there in alcohol also, like when it is like 100% alcohol, right? 100% alcohol, that is the last time that you consume alcohol, right? That සමහරලාට about 40% තියෙන liquors තියෙනවා like අර කට්ටිය ඔය එක එක fountains වගේ හදලා ගිනි තියලානේ ඔය fountain එකෙන් වැක් කරනේවා අන්තිමට cup එකකට එකතු කරලා බොන්නේ. Most of those flaming alcohol, sorry, most of those strong alcohols, what do you call alcoholic beverages, which has like more than 40-50% of an alcoholic percentage, they comes under this those things come under this flaming alcohol category. Okay, gini tibbahama alcohol is a fuel, it burns. Most of the majority of the alcohol burns as a fuel, and what remains, what comes in the bottom of the fountain is basically like a less amount of alcohol. That's why most of the high percentage alcohols are flamed before drinking, right? Alcoholic alcohol content එක වැඩිව ගොඩක් flaming alcohol වගේ තියෙන. හරිද? So basically in this case, what do they mention as as 40%? The volume percentage. That means now what you have to understand in this is not 100% alcohol. This is basically alcohol and then water. This is basically alcohol plus water, right? So in this case, if they say us it is 40%, that means from the total 1 liter, 40% is alcohol. Okay, from this total 1 liter, 40% is alcohol, and the remaining 60% is water or something else, not alcohol. So if you calculate the exact values, if it is 1 liter, you know exactly out of 1 liter 400 ml would be alcohol, 600 ml would be water. So if a person drinks the whole bottle with water, he would get 400 ml of alcohol into his body. Okay, now come to this one. In this, if you had the same size bottle, if you had the same size bottle of this one, let's imagine a 1 liter bottle. So this one also contains alcohol. What was that? This one also contains alcohol and then water as well. So in this, it says 88.8%. 8.8% is alcohol, volume basis. Okay, so what would be the remaining value? 92.2 would be water. So if he drinks this whole bottle, this person would get only 88 ml of water, 88 ml of alcohol, and he would get 920 ml of water into his body. So why do you say that this is very good? This is good. The strength of this is good, because when you drink the whole bottle, you would get 400 ml of alcohol into your body. So the situation created by ingesting 400 ml of alcohol would be better for an alcohol consumer than consuming than getting 88 ml of alcohol. Like when you drink the beer bottle of 1 liter, you consume 1 liter of beer, but you will get only 88 milliliters of alcohol. So then you can clearly understand, when you drink the 2 bottles, the person who drinks this bottle will be like moving with all 4 limbs, and this would be like not that much, because he had consumed, when he drinks the total 1 liter, this person had consumed 400 ml of alcohol. So this person has consumed only 88 ml of alcohol. So what does this percentage tells you in these liquor bottles? As a volume basis, how much of percentage out of this 1 liter bottle, how much of a volume as a percentage contains alcohol, right? So what does this percentage tells you in these liquor bottles? As a percentage wise, the volume, as a percentage wise, how much of a volume contains alcohol? Can you guys understand? Was it clear to you?
Yes, sir.
Yeah.
Elisha,
Yes, sir.
Bima, හරිද? තේරුණාද?
අද 91.2 නේ.
ඇහුන්නේ මේකද 90?
1.2 නේ.
මට තේරුන්නේ නැහැ පුතේ. මෙතන කැල්කියුලේෂන් එක වැරදි කියලා කියන්නේ.
ඔව් නෑ නෑ. මේ 100 වලින් 8.8 අඩු කරලා 91.2.
91 point කීය දෙන්නේ? 91 point ගානක් දෙන්නේ?
91.2.
බලමු. ඒකේ පොඩි කැල්කියුලේෂන් එකක් ඇති. 1000 sorry. $91.2. Oh, sorry, yeah. 91.2. එතකොට 900
when you
yeah
like take alcohol, like only 8.8% can 40% ඒ දෙක විතරයි දෙන්නේ, or it comes in different percentages too?
no, I'm not very clear with your question.
So what I was asking was, when you take alcohol, so 40% we 8.8% ඒ දෙක විතරම දෙන්නේ, or like when a values then other like percentages?
In liquors you're asking?
Yeah.
Apo, it comes in different values. It comes in different values. Yes. It comes in. I just took some values like what I mean calculation. It comes in different values, isn't it? You know. Have I 100% alcohol? You know, none. 100% alcohol booth marino. You can good arc look percentages. Make a commonly teen or kill done. Make a commonly teen or kill 40% is available, and Lanka teen me. Beer 8.8 වගේ තියෙන value එකක් කියලා මම දන්නවා. ඊට වැඩිව තියෙනවද මම දන්නේ නැහැ. And I know about this thing එකත් සාමාන්‍යයෙන් 40 වගේ කියන්නේ සෑහෙන ලොකු strength එකක් තියෙන එකක් වෙන්න ඕන. ලොකු strength එකක් තියෙනවා. හැබැයි මීට වඩා එහා පැත්තේ ඒවත් usually comes. හරිද? එනවා ඒවා ගොඩක් වෙලාවට අර දන්නද flaming alcohol category එකට තමයි එනවා. ඇත්තේ ගොඩක් වෙලාවට මේ කියන්නේ. මම දන්නේ කොතනින්ද ඒක පටන් ගන්න flaming alcohols පටන් ගන්න කොතනද කියලා. හැබැයි you can't have 100% alcohol. බිව්වොත් ඉවරයි. හරිද? So then you have to 100% තියෙන්න බෑ, ඊට වඩා අඩු ඒවා තියෙන්න බෑ. හැබැයි 80% තියෙන්නත් බෑ ඉතින්. මම දන්නේ තියෙනවත් දන්නෙත් නෑ ළමයි සමහරලාට 80% වගේ ඒවත් තියෙනවත් දන්නේ නෑ. ඒවත් සමහරට මාර ගොඩක් ඩයිලියුට් කරලා බොන්න ඕන නැත්තේ. කියන්නේ 80% ඇල්කොහොල් කියන්නේ දැන් 100 ml ගත්තොත් 100 ml වලින් 20 ml විතරයි ලික්විඩ් වෝටර් හරි මොනවාද තියෙන්නේ. 80% තියෙන ඇල්කොහොල්. ඒක බිව්වා කියන්නේ මාර ලොකු ඩැමේජ් එකක් වෙනවා. හරිද? Right? Right, so I just want you to understand this part. So then, so what I was telling to you was that we are going to indicate all the three fractions that we use to demonstrate the composition of a mixture with these two illustrations as a percentage or a parts per million. So then you can simply do this. Okay, simply we can calculate this one. Just write like this: 400 ml of ethanol is mixed with 600 ml of water. 400 ml of ethanol is mixed with 600 ml of water to make an alcoholic mixture. To make an alcoholic mixture. To make an alcoholic mixture. To make an alcoholic mixture, find the volume percentage of ethanol and water. Find the volume percentage of ethanol and water. Find the volume percentage of ethanol and water. Do it. Now, how to do it? දැන් මොකද කරන්න ඕන? Volume percentage of ethanol කියලා ලියන්න ඕන ඉස්සලා. ඊට පස්සේ මේ මෙතන ලියන්න ඕන volume fraction of ethanol නේ. Volume fraction of fraction එකක් කියලා තිබුණේ volume fraction of ethanol ලියන්න ඕන මෙතන. Volume fraction of ethanol should be that. Volume fraction of ethanol. How the volume fraction of ethanol comes? So you have to do the math. Do the math. And then multiply it by 100%. So then you have to calculate the volume fraction of ethanol here. Do it here. Don't need to write anything. Make a generally Lian equation against the lava. So in the second step, calculate the volume fraction of ethanol right here. So volume of ethanol is here is monkey way 400 ml. Right, 400 ml. I said the total mixture contains 400 and 600. That is 1000 ml. Okay, and then the 100%. Right, ml to ml cancel වෙනවා. Right, මෙතෙන්ට 18 තියෙනවා 10ක්. Sorry, 1යි 10යි මේකෙන් බෙදුවාම 40ක් වෙනවා. Right, 40%. So volume basis, 40% of the volume of the liquor bottle contains alcohol. Right? Do the math the way you understand. Right? Right, Mickey. Volume fraction of ethanol volume fraction of ethanol 400 ml තිබ්බා ethanol total ml ගාන 1000. දැන් ඒක 100% වලින් වැඩි කරන්න තියෙන්නේ. ml to ml කපලා දෙන්නම් මම ඊට ටික ඔයගොල්ලෝ calculate කරා. Done with that, guys? Ivarada?
Yes, sir.
Okay. Elisha?
Yes, sir.
Right. So then volume fraction of water. So volume fraction of water into 100%. So how much of water was present here? How much of water present here? 600 ml water divided by 1000 ml was the total volume of water and make 100% right? So then I can cut this 100 and there are 10 hundreds in 1000. 610 වලින් බෙදුවහම මේ බිඳුව කපලා දාන්න තර 16 ඕනේ කප. 60% volume basis එකෙන් 60% මේකේ volume එකක් තියෙන්නේ water. 40% උගලට අර liquor bottles වල volume percentage එක indicate කරන්නේ volume percentage of alcohol තමයි indicate කරන්නේ. liquor bottle එකේ කතාව තේරෙනවද කට්ටිය? In the liquor bottles they indicate the volume percentage of alcohol. අපිට ඒගොල්ලෝ water percentage එක දුන්නොත් දැන් maybe දැන් මේකනේ liquor bottle එක ඒගොල්ලෝ indicate කරනවා 60% water. එතකොට ගන්න හිතෙන්නේ නැද්ද? ඒ දෙයියේ මුළු mixture එකේ 60% volume එකක් තියෙන්නේ water. මොකටද වතුර බොන්නේ කියලා හිතනවානේ right? So what do they indicate is the strength like අනිත් එක තින් අර like very වෙන්නේ වතුර හින්දානේ very alcohol හින්දානේ. So they indicate the volume percentage of alcohol in the liquor bottles. Can you understand? The volume percentage of alcohol. Isn't it clear? Is it clear, guys?
Yes, sir.
Yes, sir.
Perfect. Right, Hari. So then try the Roman number 2. Try the Roman number 2. Expressing Shanuki, what did we write as the Roman number 1? Tell me.
Expressing the composition as percentage.
Okay, right. Roman number 2 expressing the composition as as parts per billion. Expressing the composition as parts per billion. So here again a fraction, ඒක volume fraction එකක් වෙන්න පුළුවන්, mole fraction එකක් වෙන්න පුළුවන්, mass fraction එකක් වෙන්න පුළුවන්. That has to be multiplied by 1 million. 10 to the power 6. I'm not going to do any calculations here right now with this. We have a worksheet. With that, we can do the calculations. Right, so we are going to indicate the composition as a parts per million. The equation is ppm equals fraction. It can be a mole fraction, volume fraction, or a mass fraction multiplied by 10 to the power 6 over the whole number in this form. So that's how you indicate the composition of a mixture in terms of parts per million. Right.